Okay, this is going to finish up chapter 16. So we are on the top of page 5, and we talk about a dry cell or an alkaline battery. So here's a C-size battery right here. So if you could saw this in half right down the middle, which believe me is not an easy thing to do, but let's say you could saw it in half and you had a cross section. All right, and this part isn't in your book, but I do want you to learn the basic parts of a battery because we use them in so many things. So you're going to draw all this out in this section of your notes. So a dry cell battery uses zinc as an anode. All right, so this outer casing right here, this outer casing is made of zinc. And that's what I have in blue. All right, I'm trying to represent that in blue. So that's the anode. Between the zinc and the cathode, which is manganese oxide, is an electrolyte. And most good batteries like Duracell use KOH, right? So potassium hydroxide. And you'll see somewhere on there it'll say it's an alkaline battery. All right, and that's what it means. KOH is a base. All right, so that's the alkaline part. All right, down the center. All right, so this part here, so down the center is a carbon rod and a brass pin, okay, and that adds strength because on the inside of all this is kind of pasty. All right, so in green, that represents manganese oxide, which is the cathode. The zinc in blue represents the anode, and then you have an electrolyte, which is like a salt bridge, okay, so it provides a source of ions and a way for a path for electrons to travel. If you connect a wire to the battery or some way for electrons to flow, and let's say we connected it to a little light bulb. It's such a great light bulb. Miss Harper would be proud. Electrons are going to flow from the negative side of the battery. They're going to go through the filament and do some useful work, make some heat there and cause it to glow, and then go back to the positive side of the battery. So that's the part of a dry cell battery. Go ahead and pause the video just a second and draw this out in the space in your notes. And you just need to know what I need you to know for the test. What's the anode? What's the cathode? What's the electrolyte? If you do that, you're in good shape. All right. Okay, let's finish this chapter up. So we are on the bottom part of page 5, where we're going to talk about, so our book does not talk about these reactions. So I wanted to finish up the book. And by the way, when you complete this, you have finished the book. All right, even though it was in the midst of a viral crisis, you have finished the book if you do this. So we're going to talk about single replacement and double replacement reactions. So a single replacement reaction is in the form A plus BX makes AX plus B. So see how A replaced B in that compound. Okay, so it's just A and B and X just represent elements. Okay, A replaced B and then B was by itself. Okay, that just means A is more reactive than B. So this is going to always be a redox reaction. Oxidation numbers will change. And I've given you an example in your notes, a famous one of zinc and hydrochloric acid, that we did in class one day, and we made hydrogen and you lit the test tube and it went like that. I don't know if you heard that. That's single replacement. You just need to be able to recognize this in a multiple choice or true false way on the test. The double replacement okay, that's going to be AX plus BY. right, makes, and then they switch places, AY plus BX. All right, so A reacted with Y and made a compound, B reacted with X and made a compound. So both are replaced. This is not redox, but you need to be able to recognize such a reaction. And I've given you an example of iron sulfide and HCl in the notes. Okay, so this isn't in your book, but it's something that was important enough that I felt like you shouldn't go through a high school chemistry class and not, you know, you've learned about formation reaction, you've learned about combustion reaction, you've learned about decomposition reaction, acids and bases. These are two really famous reactions that the book should have gone over. Single replacement, double replacement. You need to just be able to recognize them, okay? That completes chapter 16 and completes this course in terms of new teaching. So you have enough information to finish up the practice problems, the review questions, the extra practice problems, the extra practice problems. There's also an oxidation number worksheet that you can do. So I am going to wait until Monday the 23rd to update my Weebly website on when all of that will be due. But you can watch these and start working on them. If you have a question, email me. I'm happy to FaceTime if you want. I really prefer you to turn work in through the Genius Scan app, but if that doesn't work for you, email me. We'll figure out another way. If I have to come to your house and pick it up, I will do that. I do not have any symptoms as of yet of COVID-19. And by the way, the number 19 is getting a bad rap here. Okay? Everyone's going to hate the number 19 from now until eternity. And number 19 did nothing. All right? So I'm going to advocate for the number 19 from now on. Number 19 is going to be my favorite number because everyone else hates number 19. Okay, so that finishes chapter 16. Stay safe out there. Try not to get the virus. Social distance, of course. Wash your hands, and hopefully I will see you in April.